Welcome to the video lecture. Today I am going to explain DC compound generators. Based on the field winding connection, DC compound generators are two types. One is called as long shunt, second one is the short shunt. Generally the long shunt, in shunt generator only one winding is available. This is the separately excited DC generator, and this is the shunt generator. In the shunt generator only one field winding connected in parallel with the armature winding. In series series generator, both field winding and armature winding, maybe it is denoted like this, A and AA, and this is denoted Y and YY. These two are connected in series. But in long shunt compound generators, maybe the both shunt field winding and series field winding also available. So to avoid the armature reaction, and we have to provide the, generally we are using the compound generator. So here, for example, the field winding, this is the Z and ZZ. Shunt field winding is denoted to the Z and ZZ, and the series field winding is notated to the Y and YY, and armature winding is notated like A and AA. These two are connected in series, both series field winding and armature winding, and parallel together. This type of generator is called as long shunt. Why? Because entire the series field generator is connected to the a big field winding connected in parallel, that is called as a long shunt generator. Across this one terminal voltage happen. Now can replace it and provide the equivalent circuit. I told already under steady state these field windings are offers only resistances. So shunt field resistance is denoted as RSH, and series field winding it having the only that resistance RSC, and armature winding offers some resistance that is called as RA, and it is already power winding, it develop the voltage under working condition. So this is the circuit diagram. Once it is connected to the load like this, some variable resistance RL, across this some voltage will develop, that is called terminal voltage. Yeah. So what current is passing through the load, that is called as a load current. Shunt field winding carries some current, that is called as ISH, and series field winding is carries some current, that is called ISC. Armature winding carries current, that is called armature current. These are the. But in long shunt compound generators we related. So entire this branch, both series field winding and armature winding, here the field winding and armature winding connected in series. So that's why here the series field current and armature current is same. In long shunt generator, IA is equal to ISC, IA is equal to ISC, and apply at a junction some A here, apply the KCL junction law. According to that junction law, ISC is equal to here IA, that's why therefore IA is equal to, here IA is equal to entering current is equal to leaving current in that junction, IA is equal to IL plus ISH. This is another equation, equation 1 and equation 2. Now you want to find out the how to calculate this RSH value. RSH value, what are the across the voltage of this field winding, shunt field winding, both shunt field winding and entire this branch. So this branch and this branch is connected in parallel to VT. So that's why across the shunt field winding the voltage is VT. So how to calculate the ISH value? Here ISH is equal to terminal voltage VT by RSH, or otherwise once you know the ISH and VT, then you can find out the RSH is equal to VT by ISH. This is the another equation. Now we want to correlated with the external parameters and internal parameters like EZ and VT. Just write it the loop equation. Here the loop equation, this loop just I told already in the passive elements entering current where the current is entered is taken as a positive and negative, is the positive and negative, this is the positive and negative. So, these are all. Now, write the loop equation, apply the KVL, according to KVL in this loop 1. So, minus to plus, plus I can consider easy, and plus to minus, minus, it is the resistance is RA. In the RA what current is passing, that is called as IA. So, IA RA, and another resistance that is also plus to minus, that is why minus. What current is passing, ISC, what resistance, that is RSC, and here the plus to minus, minus, that is the terminal voltage equal to 0. So, here IA is equal to ISC already, that is we can write it this easy minus and IA into RA plus RSC and minus VT equal to 0. Therefore, easy is equal to what is the value, is equal to VT plus IA into RA plus RSC. RSC. So, by using these three equations, we can find out their internal and external parameters of the long shunt DC compound generator. Now, coming to short shunt compound, short shunt compound generator. This is short shunt compound generator. Here actually the series field generator, here this is the armature winding A and AA, and this is called as a series field winding, and this field winding, shunt field winding connected across only armature winding, then it is treated as a short shunt compound. This is called as a short shunt compound, Z and ZZ. So, it offers some resistance that is called as RSH, series field winding offers resistance RSC, it offers some resistance that is called as RA. Okay, here the terminal voltage. We can, you want to analyze this circuit, first of all replace their actual components and provide their equivalent circuit parameters. Shunt field winding offers the shunt field resistance that is called as RSH, and armature winding already know this, it offers some resistance that is called as RA, and this is called EC, it develop the voltage, and here series field winding offers the resistance RSC. This is the circuit diagram, here it is applied the voltage VT. Now yeah, so once it is connected to the load, it delivers the current IL, deliver the power, so it passing the current. So here this is the armature winding resistance, it carries current IA. In this junction current is divided, some current is passing through the field winding, shunt field winding, some current is passing through the series field winding. So you observe that series field resistance and load resistance are connected in series, so that is why entire this branch only one current is there. That means in the short shunt compound generator IS is equal to IL. But in the long shunt compound generator, both armature winding resistance and series field resistance connected in series. So IA is equal to ISC. But in series field short shunt compound generator, IL is equal to ISC. This is the one of the notation. Another one, apply the KCL, according to KCL at that junction, here some junction A, what is the current relations, apply KCL, IA entering current is equal to leaving current, so that is why IA is equal to IL plus ISH, this is the notation too. So by using this equation you can calculate the ISH. And another important point, how to calculate the RSH value here. So how to calculate RSH value, in the previous in long shunt compound generator both these two branches are parallel to VT, so that is why just simply can calculate the RSH values VT by ISH. But here we can, it is across the only armature winding, that is why that is not suitable. So, but how to calculate, first of all you take it this, we are apply the two loop equations, this is one equation, this is another equation. First the loop 1, from loop 1 we can write it the equation minus minus to plus, suppose I am considered easy plus easy, and plus to minus, this is the plus, this is the minus. What current is passing? IA minus IA RA, and in series field winding it is the plus entering current plus and minus, and what current is passing? ISC minus ISC RSC, and plus to minus here, this is the plus, this is the minus, plus to minus we are conduct the minus Vt equal to 0. So here IA is equal to here then this is the one of the equation, but my question another by using this equation, IS is nothing but IL, here IS is equal to IL, that is why you can write it like this also, EZ minus IARA minus IL RSC minus Vt equal to 0. This is the another equation. So suppose you know the terminal voltage at that time, how to can you find? So we can write it that this is the loop from the loop equation 1, that is the equation 3, and another one is write it the loop equation 2 here, same, EZ minus IA RA and minus, why? Because here the entering current, it is the leaving current, plus to minus minus ISH RSH equal to 0. So this is the equation 4. From equation 4, ISH RSH is equal to EZ minus IARA. So from this equation we calculate the RSH value, or otherwise ISH value. ISH is equal to EZ minus IARA by RSH. This is the one of the equation to calculate the ISH, or otherwise you want to measure the RSH value. Once you know the ISH value, once RSH is known, but you want to calculate ISH, this is the formula. Only terminal voltage is known, but induced EMF is not known. At that time, how can you write it? From equation 3, what is the EZ minus IARA value? EZ minus IA RA is equal to Vt plus IL RSC. So these two are same, EZ minus IRA is equal to Vt plus IL RC. So in terms of only terminal voltage known, but you don't know the induced voltage. At that time we can prefer this equation. We can write it that ISH is equal to, here ISH is equal to Vt plus IL RSC by RSH. So this is the formula. This is the formula to calculate it, either this equation or this equation. So induced EMF is known, but terminal voltage don't know. At that time we are using this formula for to calculate the ISH. Suppose the terminal voltage, generally terminal voltage is given to the any generator, from this equation we can calculate the ISH value. This is the formula, Vt plus IL RSC by RSH. By using these two equations we can calculate the ISH and RSH values. So concluded, this is the difference between the short shunt compound generator and long shunt compound generator. Maybe long shunt compound generator, their equations as like a shunt generator, but short shunt only you have to take either choice of this formula based on the data is given. Thank you very much.